Hey, Miss Marion here. Go ahead and get out your workbook. Turn to page 156, and you're going to read the I can statement for lesson 10. I can find missing side lengths or angle measures using properties of rigid transformations. This is what we're looking at today. So go ahead and give yourself a number. So 1, I don't remember. 2, kind of remember it. 3, I do remember it. 4, I can teach it to my friend. So remember, you need a number, 1, 2, 3, or 4, and you need a sentence about how you feel about this I can statement right now. I can find missing side lengths or angle measures using properties of rigid transformation. Go ahead and give yourself a number and a sentence about that number. We're going to go ahead and now open up our workbooks back to page 81. So on page 81, we're going to be looking at lesson 10. And so this is a copy of the workbook. I'm going to be working through it, so we're going to be kind of doing this together. If we look at page 81, we're going to be looking at this picture. And it says we're going to take this and we're going to reflect the triangle ABC over the line AB. Label the image C as C prime. So we're going to take some trace paper. So if you need some trace paper, make sure you get some. And we're going to take this picture and I'm going to label everything on here. So we have the 2, we have the 3, we have A, B, and C. And I'm going to take this and it says to reflect over AB. So AB is here. So again, we're going to reflect it. So that means we're going to take it and we're going to fold our trace paper on AB. Okay, so I'm folding it on AB. And then we're going to go ahead and we're going to reflect that. So maybe I need to come in a little bit more for you. So I took it, traced it, I folded it on AB because we're doing a reflection. And notice this is going to be my new triangle. And it says to take C and make it C prime. So see how C came over here? I'm going to now, let's see, right there. So I'm going to make this C prime. So we're going to connect these all together. Notice this was 2, so I'm going to label this as 2. And this was 3, I'm going to label this one as 3. So this is our new picture. Now the question is, since we reflected this over AB, did it change this picture? No. Did it make it bigger? No. Did it make it smaller? No. It's just reflected. So notice how B to C or B to C prime is still 2, just like this one. And notice A to C prime is also 3. So these are what are called corresponding points. So AC prime matches up with AC. Those are what are called corresponding. The sides are the same. BC is the same as BC prime because it's still 2 corresponding sides. So, and did these angles change in this triangle? No. So the corresponding angles, so the angles that match up, and the corresponding sides, the sides that match up, they are the same. So we have just done number 1. Okay. Now it says take triangle ABC prime and reflect it. So we're going to rotate it around A so that C prime matches up with B. So I'm going to take the picture. So I'm going to take my triangle, ABC prime. This is the new one. And I'm going to rotate it around A. So where I put my pencil is at A so that C prime matches up with B. So I'm going to take it, I'm going to rotate it. And C prime is actually this one up here. I'm going to want to come and I'm going to match it up with B. Oh, you know what? It didn't tell us which way. That means we have to do it to the left. Matches up with B. Did that rotation change this triangle? No. Are the sides still the same? Yes. So a rotation doesn't change this triangle. So this rotation is what is called a rigid transformation. It doesn't change the triangle whatsoever. It doesn't make it bigger, doesn't make it smaller, doesn't change the sides, does not change the angles. It's going to be exactly the same. Okay, so we've done number 2. So we've looked at a reflection, makes it stay the same. Rotation makes it stay the same. They're both what is considered rigid transformation. So what can you say about the measures of angles B and C? So measures of angle B and C. So I noticed with my triangle that I was working with before, when I went ahead and I reflected it across AB, so we took it and we folded it, notice how all of these angles are all the same. So I can actually say, oh, angle B, so the bottom one, and angle C have the same measure. And you should be writing this down also. So these are what are called isosceles triangles. Isosceles triangles, notice how the sides are congruent, but the base angles are also congruent. So something new about isosceles triangles. All right, so let's go ahead and let's turn our page. So we're gonna go ahead and we're gonna look at page 82. I made copies of this. So we're gonna look at page 82. And we're gonna come up here and we're gonna look at activity 2. It says here is triangle ABC. We're gonna draw a midpoint through AC, okay? So the easiest way I like to do it is I like to trace this triangle. Again, if you need more trace paper, please go get some. And I want to find the midpoint. That's going to be the middle point. So that means I need to find the middle point between A and C. So I'm going to actually fold this over so that A goes to C. A goes to C. And then that's my middle point. So see how that kind of makes that middle point. This middle point's right there. So this is my middle point. I'm going to label it as N. Draw a midpoint between A and C. Rotate triangle ABC 180 degrees using center M to form a triangle C prime D A. Okay, so I'm going to take it, I'm going to rotate it at here. So I'm going to draw my y-axis up and down 180 degrees. It doesn't say which way, so we're going to turn it counterclockwise. So here is 90. Okay, at 90 degrees, and then here is 180 degrees. Oops, you know what? I didn't put it on in. Let's try that one more time. M is way up here. Okay, so I'm going to do 90 degrees, 180 degrees. Oh, my M is off. All right, let's try this again. So we are going to have it. Oh, M is actually down there. M is here. All right, here's my middle point. Look, I'll show you why I noticed it was off. So I'm going to draw a line up and down. You can put it at M. You can put it anywhere. I'm going to watch this line. Here is 90 degrees. Here is 180 degrees. Notice how this matches up and kind of makes this bigger kind of rectangle kind of thing. So B is up here, and it was triangle CDA. So C, they want this one as D and A. So C, D, A. C, D, A. Okay. What kind of quadrilateral is A, B, C, and D? What kind of quadrilateral is A, B, C, and D? So if we actually look at these, notice how these two lines are parallel to each other. They're never going to cross, they're never going to intersect. And these two lines are parallel. So what we have made is actually a parallelogram. So there are two pairs of parallel lines. Kind of cool. All right, so let's look at it further. Let's look at activity number 3. So activity number 3, here is the picture, but if you look at the next page, so if you look at page 83, here is what we're going to do. So there's 1, 2, 3, and 4. So what we're doing is on page 83, here I'll kind of show it this way. So on page 83 is what we're going to do, but on page 82 is where we're going to do it. Okay? So you need to kind of be reading along with me what we're going to do. So number 1 on page 83, it says, describe a rigid transformation that takes triangle 1 to triangle 2. How can we make triangle 1 go to triangle 2? Okay, so go ahead and do that right now. And there's many different ways we can actually do that. So I'm going to take triangle 1. Here's my A, my B, and my C. And I want triangle 1 to come up here instead of on triangle number 2. Many different ways we can do it. I'm going to rotate this clockwise. Did that work? Clockwise. So see how this triangle here, I'm going to kind of shade in the triangle I'm looking at. I want this one, and then I want it to be over here. So I rotated it clockwise. Oh, how many of the rotation was it? I'm going to put my up and down line. So side to side makes it 90. Up and down again makes it 180. Okay. And that's this triangle over here. And then I can take it and go up 2, 1, 2. And to the left, 1, 2, 3, 4. So I'm going to show that to you one more time. I took this triangle, I rotated 180 degrees, okay. And then I went up 2, 1, 2, 3, 4, and then it's the same. So, okay, so I'm going to go ahead and write that down. So number 1, in here, I rotated, I turned it to the right. So that's clockwise, 180 degrees at C. So that's where I put my pencil. Where did I put my pencil? I put it at C, down here, okay? And then I went up 2 units and left, how many was that? So I had it here, 1, 2, 1, 2, 3, 4 units. I'm going to write that, 4, and left 4 units. Okay. Now let's read number 2. It says, describe a rigid transformation that takes triangle 1 to triangle 3. So here's my triangle again. So triangle 1, and I want to make it up here. So I'm going to try the same thing. I'm going to take it, I'm going to rotate it. Let's see, that way. So that's counterclockwise. Oh, I need my y-axis, my y stuff. So I'm going to watch this. Going side to side, that's 90 degrees. Going up and down, that's 180 degrees. Okay, so this is the triangle I'm looking at, and now I need to make it up here. So I'm going to go up 1, up 2, to the right 2. Okay, so I'm going to write that down on number 2. I said rotate. So we rotated, or rotate. I'm not going to put it in past tense. I went counterclockwise, 180 degrees. Oh, where did I put my pencil? Oh, I put it at B. Okay, at B. And then I went, that kind of brought me here. And then I went up 2 and right 2. Okay, so doing all this, did this triangle change from the two. No, we're still doing a rigid transformation where it keeps it the same. All right, so now we want to, if we look at number 2, find 2 pairs of line segments in the diagram that have the same length. Okay, so 2 pairs of line segments that have the same length. This is what I'm looking for, and I want to find it so that they're the same. So think about it. All right, so what are 2 different points, or sorry, 2 different line segments that are the same? So I'm going to say that C to D and AB are the same. So I can take my trace paper, see how this triangle is the same as that triangle, and the corresponding points, so the kind of the pieces that are all the same. So I can say CD and AB. Or, okay, what else can I say? Okay, let's look at this a little bit further. I'm going to say these 2, EB and AC. Those are the same. What about those bottom stuff? I'm going to say that these bottoms are the same. AE and AD. Can I also say that AE and BC are the same? Yeah. Why are all these the same? Well, remember how we took with our trace paper, we made that triangle 1 to become triangle 2. So they have the same pieces. And then we took triangle 1 to make it triangle 3, and they have the same pieces. Okay, so here are sides that are the same. Now, if we look at number 4, so this was side lengths. Now we're looking at angles that have the same measure. So these are corresponding sides. Corresponding sides are the same sides of the different triangles. Now we're looking at corresponding angles. Okay, so I'm going to say the angle E, so this BEA is the same as CBD. I want to say these 2 are the same. Well, if those 2 are the same, and that's the triangle there, and we were doing rotations, right? Which one? Oh, so this one is also that, goes along with it. All 3 of those angles are the same. All right, so let's find some more. What about this angle BAC? What angle is the same as that one? All right, so remember I took it. Oh, let's come up here. Let's do triangle 2. So I rotated it right and went up and over. Oh, that angle A is the same one here. Okay, so these are all, those 2 are the same. Well, which one is up here in this triangle? So we took it, I rotated it at B, right, and then I went up to, so I was looking at this angle A. Oh, that means that one is also congruent. Well, that's kind of cool. And then with the last angles, can we say that this angle is the same as this one? Yeah, how did we do that? We did that with that trace paper. Can I say this one is also the same up here? Absolutely, because we did it with the trace paper. So what we're looking at is when we take rotate, translate, or reflect, the corresponding, so the same angles have the same measure in the new picture, and the same sides have the same measure in the new picture. This is what is considered corresponding sides or corresponding angles. Awesome, that's kind of cool. So we've done number 3 and we've done number 4 with highlighting on this triangle picture. All right, so let's look at the next page. Okay, so we want to look at it and we want to go, okay, we're going to take this triangle and it says reflect ONE across ON. So take this triangle, reflect it across ON. So you might need a new piece of trace paper. ONE. ONE. And I'm going to reflect it. Oh, this is, how many degrees is that one? 30 degrees. Is it 30? Yep, 30 degrees. And then this one is 5 degrees. So I'm going to reflect it across ON. So that's where I'm going to fold my paper on ON. Okay. So we're going to take it. I'm going to reflect it. All right, so here is that new point. And they wanted us to label a new point M. So this is here. This is here. Notice how the 5 is the same. And then up here is 30 degrees. So this is my new triangle. Okay. So what is the measurement of MON? Or sorry, MON. So what is this new angle? This angle is 30 degrees. What is MOE? So that's a 30 and 30. That's 60 degrees. So if we kept on doing this over and over again, we would have that same triangle over and over again. We're going to skip number 4, and we're going to skip number 5. Okay, so again, when I do a translation, rotation, or reflection, those pieces of whatever we're rotating are exactly the same. They have the same measure, and they don't change whatsoever. So notice how we have all of these. So this is actually what we're looking at today, as far as we're seeing that when we take different things, it's a rigid transformation. It's not going to change the picture. It's going to be, the picture is going to be exactly the same. So notice on here, we took this and I reflected the green over AD. I made the blue. Those are exactly the same. All the measurements are the same. The angles are the same. So corresponding angles, so the sides that match up, corresponding sides. The angles that match up, the corresponding angles, they're going to be exactly the same. All right, so go back to page 156. Let's read the I can statement again. I can find missing side lengths or angle measures using properties of rigid transformation. So go ahead and give yourself a number again. So 1, I still don't get it. 2, I kind of got it. 3, I did get it. 4, I can teach to my friend. Give yourself a sentence. So do a self-reflection. Hey, how do I feel about this? Do I need to ask more questions? So go ahead and give your number and a sentence. All right, so our homework for today, we are doing practice problems for this lesson. Starts on page 87. We are doing 1, 2, 3, and 4. So again, we're doing numbers 1, 2, 3, and 4, and then this also goes into Canvas. Okay, thanks. Have a good day. Bye.